Hello guys, this is Kamuti Given from Kamuti Academy. Welcome back to this other episode. Today we'll be looking at a topic in mathematics, and this is bearings. This is a paper 1 topic. Okay, so now let's look at this question that we have on the board. In the diagram, angle BAC is 46 degrees. So this is angle BAC 46 degrees, and AC is equal to BC. So from A to C, the line AC and the line BC, they're the same. As you can see, these two lines are the same. Then B is due east of A. So B is due east of A. So that's the instructions. Those are the instructions that have been given. Then the question now, calculate the bearing of A from C, then part B, C from B. All right, so follow me. Let's go together. We solve these two questions. So solutions. Okay, so we start with the first one. So part A, bearing of A from C. All right, so when you're dealing with bearings, there are two things that you're supposed to consider. The first thing is that you always consider the letter that comes after from. So you start with the letter that comes after from. Then the other thing is that we move in the clockwise direction. We always move in the clockwise direction. All right, so now they are saying the bearing of A from C. So meaning we're going to go where C is. Have you seen? So we make a north here where C is. So we're going to make a line like this. So I'm going to make a line. So I've made a line here. So we've made a line here. From there, then now they're asking us to say, so let me just remove this C here so that I write it from this side. So this is our point C. So now they're telling us to find the bearing of A from C. So this is the point A, and that's the point C. So we're going to move from the line that we've drawn from C here. We'll move in the clockwise direction, then all the way to the line that is connecting the point C and the point A. So this is where we are going, in the clockwise direction. So we're looking for this angle in order for us to find that question. Now, how do we go about that angle? Follow me. This is a straight line that we have drawn. So angles on a straight line are equal to 180 degrees. So this angle on its own that we've created here, just on a straight line here, this is 180 degrees, this one. But what about this one, the small one, which is inside? So meaning we need to find this angle so that we can add it to 180 degrees. Now, how do we find that angle? There are different ways in which we can find that angle, but let me show you one of the ways. So from the instructions, we've been told that B is due east of A. This simply means this is a straight line. AB is a straight line, and there is at the end of A, there is a line here, there is a north, which is also a straight line. This simply tells us to say this is a 90 degrees. So the angle here, it is 90 degrees. This one, this is a 90 degrees angle. So now, after knowing that that is a 90 degrees angle, then we have 46 degrees here. Then to find the angle here, we're going to say 90 degrees minus 46. What is 90 degrees minus 46? You can do that on a calculator. So we should get 44 degrees. We should get 44 degrees because when we add these two, we should get 90 degrees. Then now again, the 44 that we found here, since we've created a straight line here, so this line and this line, they are called parallel lines. So now when you've got two parallel lines that are separated by a line that we call a transversal line. So this line here is actually called a transversal line. So in this case, what we have, we more like have what we call Z angles. So if you are not sure about angles, I'm going to do a separate lesson about angles so that you can understand. So this 44 degrees, it also goes on here. So this also becomes 44 degrees. Why? Because of these two parallel lines separated by a transversal line. So this is 44 degrees. So to get now the total angle here, we just add. We say 180 plus 44 degrees. So follow me. So I'll say 180, then we add 44 degrees. So we have a 4 here. Then we say 8 plus 4, we get 12. We'll say 2 carry 1. Then we have a 1 there, we put a 1 there, it becomes a 2. So the final answer is 224 degrees. That is the answer for the first question. Hope you get me. We go to the second part. We calculate the bearing of C from B. The bearing of C from B. Remember, I said you always follow the last letter there. So we are interested at B here. We're going to draw a north here at B. We're going to draw a north like that. Okay. All right. So now, what we're going to do now is that we're going to move from B all the way to the line that is joining C. Right. So we're going to move from this point in the clockwise direction all the way to the line that is joining C. We're not going to end here because this line is joining A. We're ending here because this line is also joining C and B. All right. So now our question now here is to find the angle here that we have created. We need to find the angle here that we have created. Now remember, in angles, if you're familiar with angles, there is what we call a complete revolution. Angles in a complete revolution is 360 degrees, meaning it's a complete circle. So in a complete circle, angles add up to 360 degrees. Now, because of this part that is remaining, this angle is not adding up to 360, but if we add this part here, the small part, it will add up to 360. So one of the ways we can find this angle is we can find this smaller angle and then subtract from the entire angle. So how do we go about that? So follow me. So we can say we have the angle here from there to there. This is 180 degrees. All right. Then we are only interested in this smaller angle. This is the only angle that we need. If we can find this angle here, then we can also find this angle here. So that is actually one of the ways that we can find. Then we can also check, do we also have other parallel lines that we can confirm with? Right, so already this one is a parallel line. Then this also is also parallel to that one. So initially what we can do is that the angle here, the angle that we should get here, and the angle that we have here, these two angles should be the same. Why? Because we have a straight line here and we have a straight line. If I extend this line and I extend that line, we have got two parallel lines that are being separated by what? By a transversal line. So this simply means the angle here and the angle here should be the same. So now, how do I find the angle here? I know this angle here is 44 degrees. In order for me to find this angle, it's simple. What am I going to do? We've been taught to say that these two lines are the same. Now, if two lines are the same in a triangle, it's actually called an isosceles triangle. These two lines are the same. It simply means even their angles should be the same. If this is 46, this should also be 46 degrees. Have you seen? So we have 46 here. We also have 46 there. So now, how do we find that angle there? Remember we said 46 plus 44, that's 90 degrees. Then 90 degrees, we add a 46 degrees, then we get 136. So to get the entire angle now, because a triangle, angles in a triangle, they add up to 180. So we're going to say 180 minus 136. 180 minus 136. So here we have a 7, here we have a 10. 10 minus 6 is a 4, 7 minus 3, it's a 4. Then we'll get a 44. So we are having a 44 degrees here as well. So even here we'll get a 44 degrees. So meaning, since we have a 44 degrees here, and what we're interested in is this one here. So in order for us to get this final answer, so let me put it here. So part B, where we are saying C from B, in order for us to get that answer, I'll say 360 degrees subtract by 44. So I'll subtract 44 from 360 degrees. How do I get that? So 360, a 44 there. We do some subtractions. There we'll get a 5, 10. 10 minus 4 is 6. Then 5 minus 4, that's a 1. 3 minus 0, there's a 0 there. We just get a 3. So the final answer is 316 degrees. So these are the solutions that we've gotten for part A and part B. If you have any questions, feel free to ask in the comment section, and I'll be there to attend to the questions. Thank you so much.